Automatic. Addison.
In this tutorial, we are going to learn advanced concepts for object-oriented programming in Python. Let's learn about writing getters and setters. Getters and setters are like security guards for your robot's information. Think of them as special functions that help you safely check and change your robot's settings. Just like you wouldn't want anyone to accidentally set your robot's speed to a dangerous level, getters and setters help protect your robot's information and make sure it's changed in the right way. Let's open up a terminal window. Let's move to our favorite folder. Open the code editor, Visual Studio Code. Let's close everything over here, clear it out. And let's create a new file called robotsettings.py. Robotsettings.py. And we will define a class named robot that will help us manage the speed and battery level, which are common attributes in robotics. So let's start by doing class robot. First method, our constructor, init. Okay, and let's do, when we create an object of this class, we want to initialize it with the speed. Okay, set a default value of 0. If none is specified, and then battery level of 100. Okay, and member variable self.speed. And I put this underscore, which is a very common convention for member variables, to put an underscore right here. So self.underscore speed, and then equal to speed. And then we'll do self.underscore battery equals battery. Okay, and let's do our method. Let's do def get speed. This is a getter, get speed, self. And we want to return the speed. Okay, and let's do a setter. This will allow us to set the speed. Set speed, self, comma, value. If value is less than 0, raise value error. Speed cannot be negative. And we'll do self dot speed equals value. Okay. So you see here, it does a check to see if the value to which you want to set the speed is less than 0. And if you do that, it raises an error. Speed cannot be negative. Otherwise, it just takes the value of value and it puts it into the, stores it inside the member variable self.speed. Now let's do the same thing for getting the battery level. So def get underscore battery. And let's do self. Return self dot battery. Let's do def set battery to set the battery value. Open parentheses, self, comma, value. Say if not 0 less than equal to value less than equal to 100. So raise value error. Battery level must be between 0 and 100. This is our error message. This is good practice. Best practice is to have things like that, little checks. If the user enters in bad inputs So self battery, and we take the value of whatever the user puts in here for setting the battery value. So this code snippet right here, let's go to the top. Let's add some space here. See if we can add space so you can see everything. Let's go to the top. Come on, baby, go to the top. So we are creating our class, our blueprint for an object. We have our constructor here. And if we do not, when we're creating the object of this class, specify the speed in the battery, it'll by default set the speed to 0 and the battery level to 100. Otherwise, you can specify these variables when you create the object. Now we have our getter for getting the speed, okay, getting the value of the speed member variable. We can also set the value of the speed member variable, and we can do the same for the battery level. We can get the battery level, and we can set the battery level right here. Now let's run a simple test to see these getters and setters in action. We'll do that below here. So we'll create our object, robot equals robot. Okay, and we're not initializing it with any values for the speed and the battery level. So we'll just use the defaults, and we'll do print initial speed, comma, robot dot get underscore speed. And we'll do robot dot set speed 5. And we'll do print updated speed, comma, robot dot get underscore speed. We see it right there. Okay. So let's down here, let's do try robot dot set underscore battery. And let's put 150, some bad value. We know the robot battery level cannot be 150. It has to be between 0 and 100. And we'll raise an exception, except value error as E. Then print E. Now let's save and run the code. So we see initial speed 0. We set the speed to 5. Our updated speed is 5. And now we tried to set it with some bad value, the battery level for some bad value, 150. And we get our value error raise, which says battery level must be between 0 and 100. So that's exactly as we expected. So you can see how the outputs here show the robot's speed updates and any error messages that are related to the battery level adjustments. Now let's talk about inheritance in Python, a topic we briefly covered in the previous tutorial. Inheritance is like creating a family tree of robots. Imagine you design a basic robot with common features. Then just like how a child can inherit traits from their parents, characteristics from their parents, you can create new types of robots that automatically get all the abilities of the basic robot, plus their own special features. This saves you from having to write the same code over and over again. Let's see it in action. We'll create a new file called robot underscore inheritance.py. And let's begin by defining a base class, a parent class called robot, class robot. And this class will contain the common attributes and methods that any robot might need. So def init. Okay, let's go over here and let's give it the name attribute. Every robot needs a name. Our member variable, self dot underscore name equals name. And let's give it a method. Let's do greet. self, print f string, and we do hello, I am self dot name. Save. Let's go down here to class cleaning robot. Def clean self print cleaning in progress. Okay, so notice how a cleaning robot doesn't redefine the constructor, the init method, or the greet method, but inherits them from the robot class right here. It does, however, add a new method called clean, which is specific to cleaning robots. Now let's add some test code at the end of your script to create an instance of the cleaning robot and to use its methods. So my robot equals cleaning robot, and let's do robo cleaner. Do my robot dot greet and do my robot dot clean. Now save and run the script. Hello, I am a robot cleaner. There's our greeting. Hello, I am a robot cleaner. I am robot cleaner right here. It's the name of our cleaning robot. And then here we have our new method, which is cleaning in progress, so robot.clean, which is specific to the cleaning robot class. So you can see how the greeting from the robot appeared, followed by the cleaning message. So this demonstrates how the cleaning robot uses functionality from the robot base class, parent class, while adding its own unique behavior. Okay, let's clear this out and let's talk about another key concept in object-oriented programming called polymorphism. Typing that here. So polymorphism literally means many forms, but imagine you have a television remote control with the power button that works on different TVs. Let's see if we can bring that up here. Going to Firefox. Okay, let's go to Google. Okay. And let's say universal remote control. Okay. And let's pull the image up. Okay, so here's our remote control. Open image in new tab. All right, here's our remote control. So imagine you have this television remote control, okay, and it has a power button. And this power button works on different TVs. So just like how different television classes, you have Samsung, LG, or Sony, all understand the same power command, different robot classes can share common commands too. So this is polymorphism in action. We can treat different kinds of objects, like our different robot types, as if they were the same basic type, so like a general robot class. For example, all our robots might understand the command move forward, but each robot class implements it differently. So a walking robot might take steps to move forward, but a wheeled robot would roll forward on its wheels. Same command name, different behaviors. Let's see this in action. Let's close this out. Create a new file called polymorphism example.py. Example.py. And let's start by defining a base class, a parent class called robot. Def init self, comma, name. Okay, and let's do our member variable self dot name equals name. And let's do def, and let's create a method called perform task. Say print f self dot name performs a generic task. Okay, and save. Now let's define two subclasses, two child classes, okay, of that parent class, the base class, that inherit from the robot class but perform tasks differently. So this will demonstrate polymorphism. So we'll create a class. Let's call it cleaning robot. Inherit from the robot class. And let's do def perform task. Okay, and let's do print f. Let's do f string, and let's do self dot name. Okay, is cleaning the area. Okay, I need to go up here and add an underscore. So it's self dot name. See what this is barking about. Self dot name. Let's copy paste. Okay. All right. And now let's copy paste so we don't have to do. Let's do another type of robot called a painting robot. Okay, let's go over here. Let's do a painting robot. Painting robot. And let's do is painting the wall. So you can see we have our parent class, our base class right here, robot. And then we define two subclasses, two child classes right here. They inherit from the robot class, but they perform tasks differently. Each one has their own implementation of the perform task method. It's tailored to what the specific robot is supposed to do. This one cleans, this one paints. Now let's add some test code. Let's create instances of each robot and call their tasks method. So we do robots equals cleaning robot. And let's do open parentheses, cleaning, and then comma. Let's do our other one, painting robot. And let's call it painty as the name. For robot in robots, robot.perform task. Save. Now let's run the script by pressing the play button. So cleany is cleaning the area and painty is painting the wall. See that? You can see how each robot performs its specific tasks, cleaning and painting. So this demonstrates how polymorphism allows us to use a common method in different contexts, a common method in different contexts. So this concludes our overview of advanced object-oriented programming in Python. Thank you, and I'll see you in the next tutorial. Keep building.